Welcome to the lecture in Philosophy of Science. Today we apply our insights on the dynamics of theories and theory testing, which we illustrated last lecture at hand of an example from the theory of mechanical physics. Today we illustrate and discuss theory dynamics at hand of an example of a theory from psychology, namely the theory of cognitive development from Piaget. Jean Piaget was a psychologist in France, and he started his work as early as in the late 1940s, and he studied the development of intelligence in children. So generally speaking, the development of, on the one side, of cognitive abilities in children, and in the other side he also studied the development of moral thinking in children. But I speak today about his theory of cognitive development. So Piaget was very influential in several, at least three scientific areas. On the one hand, he was one of the founders of cognitive developmental psychology. And even if the more detailed assertions of his theory are now rejected or modified or revised, the general idea is still there. Cognitive developmental psychology, that at certain ages or stages the children develop certain cognitive abilities. So that is still there today. Secondly, at that time, of course, Piaget was a very strong, so to speak, a very strong opposition and statue in opposition to the camp of behavioral psychologists or behaviorist psychology at that time. You know, Skinner and so on, those guys who said that almost all kinds of learning are reducible to trial and error learning, while Piaget was highly influenced, and that is the third thing, by philosophy, namely by Kant and philosophers who said, no, in order to learn from experience, you must have certain very general cognitive operations in mind, right? You must have them in mind already in order to be able to learn from experience, to systematize experience. But then, thirdly, Jean Piaget is often put into one camp with Konrad Lorenz, because Piaget observed, he started with observing his own kids, by the way, his own babies and so on, and he observed that, well, these very general principles which Kant thought a priori, somehow a priori in all intelligence minds, they really develop in the kids at the very early age, and they spontaneously occur at certain ages, right? And that was what fascinated Piaget, this genetic development of a priori, of structures which Kant thought to be a priori. Therefore, some people call him Piaget, a genetic epistemologist. Okay. So, what was the core thesis? You know, remember from the last time we have theory versions and theory cores, right? And this is Piaget's theory version. Then let's start with the core. And so in the core of his theory there's this assertion, namely the development of intelligence in children rests primarily on the step-like formation of generally applicable logically structural abilities. I will illustrate that in a moment. Say, for instance, the concept of number is learned at a certain stage, say, is grasped at a certain age, like 6 years, then it can be applied to all kinds of domains. Or if, say, for instance, the concept of transitivity, so if this is longer than that, and that is longer than that, then this is longer than that, right? If A greater B greater C, then A greater C. If this principle of transitivity this principle of transitivity is learned, at some age it is grasped, and then it can immediately be applied to all kinds of situations because the structure is learned then, right? So that is the Piaget's core thesis. Generally speaking, the psychology of Piaget, and this is not on the slide now, but generally speaking, this psychological theory of Piaget teaches tells that, so to speak, there are following phases. So with 2 years, so this is 2 years, this is called the sensomotoric stage of the cognitive development of the kid, from 0 to 2 years, right? And at the end of that phase, or at the beginning of the new phase, the kid learns a certain structural system, ability or system of abilities. And what the kid learns in the sensomotoric stage in the first 2 years is orientation, according to Piaget, orientation in space, and the principle of the preservation of the object. This is also a Kantian principle, right? Namely, meaning that if an object disappears visually, you cannot see it anymore. For instance, because a ball, which the kid likes, the baby likes, is rolled behind a screen, the kid learns that the ball is still there and crabbles, right? Crabbles behind the screen in order to get the ball, right? So this is what the kid learns in this first 2 years. And all the orientation in space, like it learns that there's even if the door is closed, there's a room behind this door, I can go to there, I can go backwards, and so on. From 2 to 6, there's the so-called pre-operational stage. The pre-operational stage. And here the kid learns majorly the language, and it starts to struggle with certain principles which it doesn't understand. Certain operations, that's why it's called pre-operational, it doesn't understand certain principles like the principle of transitivity and other things, right? I will explain that in a minute. But with 6 years or 6 to 7 years, nearly all children at a sudden master these operations, which for Piaget form certain logical structures of operations, and that is called then the operational stage. It's called more specifically the concrete operational stage, which goes until 14 years. The concrete operational stage. At the beginning of this is characterized with certain operations and principles, which I explain in a minute, are learned. So in that, it's no accident, that elementary school starts at 6, right? I have to tell you also that Piaget's developmental psychology was very influential for all kinds of education theorists, pedagogues, right, teachers, and didactic theories. So because it was very important, right, if the kids learn are able to learn certain principles only after the age of 6, and there is not much point in having school starting already at the age of 4 or 5, etc. And also, if it's true, if Piaget is right, for instance, that there are very abstract structural abilities underlying kids' cognitive intelligence, like set theory or set theoretical structures, then it makes a point to teach set theory in elementary school already, and that, was really, for a certain decade, was really what was going on in elementary school. That they start to teach elementary set theory in the 4th grade of elementary school, but then later on they stopped to do that because it was too abstract. But that was very influential, the whole Piagetian controversy for education theorists. What is important is in that stage, Piaget says, so it's confirmed by experiments, of course, Piaget did all kinds of experiments, it's in that stage, the mastership of these operations is bound to interaction with concrete objects. So the kid masters certain rules like transitivity, but it cannot abstractly formulate these rules. It behaves according to the rules, but it cannot reflect, right, these rules and formulate the rules themselves, right? While in the so-called abstract operational or formal, that's a word, the formal operational stage, which starts at the age of 14, according to Piaget's theory. Now the adolescent or the young people, the juvenile, has this ability to reflect and understand the rules which our brain follows, like logical rules, and it cannot write down really the rules. But for instance, modus ponens is mastered by the kids already at that age, right? But to write down the rule of modus ponens, that is an activity which you can only do at this stage. And it's no accident that in that age, right, in high school, around that age, you start to learn juveniles, the pupils, you learn them abstract equation with variables instead of just numbers. That's just when you start the most simple variable equations like x plus 3 is 2x. So what is x, right? X is 3 in that case, obviously, and so on. So that is all related to that. So that is the general framework of the Piagetian theory. Now I focus my example here on Piaget's theory of the concrete operational stage. So what is learned here? So in that, so to speak, new step which the intelligence of the child reaches around the age of 6 to 7 years. Okay, so this is first specified by 3 further laws, which are again theoretical laws and are not really laws which tell you how that is connected to empirical behavior. It says, the concrete operational stage is characterized by the formation of the following competences. The first competence is change of perspective. Now this is a very general competence, and it means that with the age of 6 or something like that, the kid is able to take over the perspective of another person. I will illustrate this, you will see later. The most easy illustration is visual perspective. Now this means, if I'm asked, how does this room look from the perspective of Sarah, sitting there behind the camera, then with the age of 6 I'm able to imagine that in my mind, how it looks from her. So there must be the camera in front of her, and at the side behind them somewhere is this strange guy, me, talking about some things, right? And so that's like, this room looks from her. So before the age of 6, kids cannot do it, right? But change of perspective is a much general ability, although change of visual perspective is still general enough, right? But for Piaget it's more general even than that, because, as I told you, Piaget has also the theory of the moral thinking of children, and there he has a parallel idea, a parallel theory of stages, and he says that before the age of 6, children are pre-conventional in their moral thinking, which means they don't understand the general social norms and moral norms. They just do what they have to do by punishment and reward, being rewarded and being punished, right? That is pre-conventional, right? They just maximize their utility without looking on moral rules. But at the age of 6, they understand what fairness means. That is exactly that I take over the perspective of the others. I can imagine that, well, that's unfair, right? He has got candies and I don't. That's unfair, right? Or things like that. Or he can play with the doll, but I don't have a doll. I don't want a doll. That's unfair. So, I mean, you should treat people equally. And the basic ability here is to take over the perspective of the other in terms of the other's interest. So if I would be in the situation of the other person, how would I feel? Like, I mean, if the other person has not candies, but I have candies, I can imagine that it would be bad for the other person not to have candies, because I know what it means for me not to have candies. So I understand that the other person complains, and in this way the kids get a general feel of fairness based on certain rules of moral, basically saying that all people should be treated equally. This rule these rules are general and apply to all persons, right? And all of you know who have experiences with kids that really at the age of 6, kids develop a very strong sense of fairness. That's unfair. You are allowed to do it, and he is not or I am not. That's unfair, right? That's absolutely clear. And that's also coupled to this general idea of Piaget that at that age people are able to take over the perspective of other persons. Okay. So this is a core rule C2. Then there are two further core principles concerning the concrete operational stage. Namely, Piaget says that with the age of 6, kids understand that certain physical operations by which you change the shape of objects or by which you change their distribution in space, by these operations can be reversed. And because they can be reversed, certain properties remain invariant under these operations. That is a very important theory of concrete operational, of this operational intelligence. Actually, Piaget reconstructs this system of reversible operations and the invariances in the way of Bourbaki as a certain mathematical structure of a group. So he's very influenced by the Bourbaki tradition. And group theory, and you know, physicists know that group theory is connected to symmetry, and symmetry theory, even in physics, is connected with the major invariances. So it's a very, very nice, beautiful theory there. But what Piaget claims is that this beautiful abstract theory, which the most intelligent mathematicians and physicists have reached in the 19th century, is somehow already in the kid, right? And pops up somehow in the age of 6 to 7. So let me give you the major example for this part of the concrete operational intelligence. It's done with experiments with clay balls or plasticine balls. If you pull them apart to a long sausage or stretch them, you ask the kid, is this now more or less, right? And before the age of 6, they systematically say, well, it's more because it's longer. And after the age of 6 or 7, they say, no, the amount of clay is the same, has stayed the same, of course. And you ask the kid, why do you think so? And the kid says, well, I could compress it, I could reshape into the original form of a ball, right? And therefore, the amount of clay has stayed the same. So that's how the recognition of the reversibility of this operation is connected with understanding that the amount of substance is invariant under change of shape. And he has lots of other experiments. For instance, water in glasses. If you have a glass, a small glass which is quite broad, and then you pour this water into a glass which is smaller but high, then the level, of course, is raised, and he asks the kid of an age of 4, is this some more water? And they would say, yes, no, it's more water, it's more. Oh, nice, beautiful. And then, please pour it back. Well, no, it's less, right? But with the age of 7, almost all kids understand that the amount of water has, of course, stayed the same. It's just the form, the volume, the form which has changed by pouring it from this glass into that glass. And again, the reason for that is, the reason which they give is that they can invert this operation. They could pour the water backwards, and then you will see that it's just the same level as it was before. So this is the major application domain for this principle of reversibility of operations and recognition of invariance. And that's nice, and let's lead us to the first, to the couple of special laws in Piaget's theory. So far, as I have reconstructed this part of his theory here, all laws are theoretical. They are core laws, right? Now, the special laws come. The first special law, S1, says that at the age of 6 to 7 years, children have reached the concrete operational stage, as I said it, And of course here you see there's a further difference between psychological theories and physical theories, which you really find in almost all theories. Namely, clearly this law is actually not a strict deductive law, right? Not really 100 exactly all year, but it's a statistical law. Of course some kids have a delayed development, some kids have an accelerated development, and of course what is said that if you have this stage theory, well, let's say here 6.5 years, something like that, then of course you have some kind of distribution here, right? So, right. Almost all, say 95% of all kids master this stage between 6 and 7 years, right? That's a statistical assertion. So that is also an interesting remark that in almost all theories which you have in psychology you have these statistical laws, because there are simply too many possibly disturbing factors which are very rare but which influence the statistics, so that you cannot come up with a deductive theory like in physics, with a strict theory. Where you really can list all possible forces at the theoretical level. You can do that in physics, right? The sum of, you remember last time when we spoke of the Newtonian sum, the sum of all forces. You don't have a sum of all forces term in psychology. You don't have it. But you have these statistical laws. Okay, so this is the first interesting point. S1 is a law which connects theoretical concepts, concrete operational stage, with empirical concepts. And then we have special laws S2 to S4, which, as I have already explained, relate to these abstract competences here, certain domains to which they typically have to apply it. So S2 says, for the change of perspective, a typical example is the coordination of different visual perspectives. Visual perspectives, right? Namely in the domain of cognitive intelligence. And S3 and S4 say, for the development of reversibility and invariance, one typical example is the invariance of the amount of substance with respect to changes in shape. I have already explained that, right, with a ball of clay which is stretched to a sausage and then compressed back to a ball. And the other famous example which Piaget gives is the invariance of number with respect to different orderings, right? And the example which he presents here concerning the concept of number is the following. The test operation is very simple. So you have little cards, and either you have coins on them, right? And it's like 5 coins. And here these coins are quite close to each other, and in the other card they are distributed, they're far apart from each other, so they take much more space. Either the coins are really, either the experiments are done with real coins or just with photos of coins, it doesn't matter. And you ask the kids, is this more, less or equal a number of coins? It's a number of coins the same, more or less, on this card then compared to this card. And with 4 years the kids say, this is more. There are more coins here. And with 6 or 7 years the kids master the concept of number and realize that they are the same number of coins, right? So this is a number test that Piaget designs. And so I proceed now to this part of the theory. These are these concrete indicators. For the change of visual perspective, and now we are here at the concrete indicator laws, the laws of correspondence, which really connect these concrete competences, which by these laws are already related to certain domains of application. Now they are correlated to concrete tests which lead to a concrete behavioral result, right? And they were called selective tests or selective indicators because they should measure exactly these abilities which are mentioned here. For the visual change of perspective, Piaget had a certain mounting test, right? The mounting test was going as follows. I didn't explain that. So it looked like that. There's a table, right? And on each side of this table there's a chair. You really can also imagine, right, some little kids sitting on these chairs, right? So you could say Susie, Peter, Ralph and Mary is sitting there, right? On this table there's an object. The child, which is to be tested, goes around this table several times, and then it is taken aside, so like 5 meters apart, and then it is asked, how does the object on this table look from that position, from the position of Mary? And it shows certain photos, like 4 photos, and you should choose. It looks like that. And how does it look from that position? It looks like that, right? And the object which Piaget used, that is now crucial, was a mountain consisting of 3 peaks. Quite a, not an easy object, right? Such a thing where a certain peak is is covered by another peak, depending on which side you look, right? So that's like. So that was the test of the change in perspective, which Piaget's mountain test, and it turned out the children master this test with the age of 6 or 7, but not before. Right? Okay. For the concept of the invariance of number, Piaget used the explained number test, and for the concept of the invariance of the amount of substance, Piaget utilized the explained clay ball test. Right? So that is now, what you have now here in my reconstruction is exactly the full theory version of Piaget's account, which contains all things which you need to get predictions. And this theory version was valid for at least 2 or 3 decades. So what is the prediction? The prediction is nearly all children fail Piaget's test before reaching their 6 years, but successfully complete Piaget's test upon reaching their, say, 7 years. So they give them an interval of 1 year, right? A statistical distribution where at least the 2 sigma interval should be in it, or a 3 sigma interval. I mean, that's some kind of minor issue. But that is the theory. So, any questions up to now? If not, then I go on. So what was now the development of this theory? Well, of course, several psychologists in that area of cognitive psychology replicated Piaget's test. And they, of course, designed new experiments where they varied the indicators. And what was the outcome? The predictions were confirmed when one uses Piaget's indicators. And I mean, Piaget was a very careful empirical researcher. He did these experiments, his specific experiments, again and again. He had a team of several psychologists himself. But if you use different indicators, which are equally plausible, remember my general rule, which I told you last lecture, where I said if indicators for theoretical concepts in social sciences are equally plausible, you should test your theory core with all of them. That was what Piaget didn't do. So if the psychologists used different indicators, the predictions were disconfirmed. And so that was the problem. Now I tell you two major examples where these problems have been studied. So the first example is the example of visual perception. It's quite obvious that, it's quite obvious that a mountain formation like that is difficult. I mean, if you're a mountain climber, you know from experience how difficult it is to recognize a mountain from different angles, which consists of several peaks covering each other to some extent. And of course people said, well, let's do the visual perspective test with a more simple example. Let's just take a box consisting of 4 sides, right? And each side has a different color, right? So, you know, there's blue, there's red here, green here, blue here, and yellow here. Okay? So that's really a very basic thing. It's just the colors. So it's really much more selective for the pure qualitative principled ability to take over the visual perspective of another person. In the mountain test, you know, you have to rotate your the system of 3 mountains in your mind. That's a complicated thing, but here you just have to remember which color is on which side. So again, the kid goes around the box, the table with the box several times, memorizes these colors, and then it is led aside and asked, which color does the box have from the position of chair 1 of Susie? It's green, it's red, right? From the position of Mary, it's yellow, and so on. And then it turns out with this simplified perspective test, the children already in the age of 3 to 4 years mastered that, right? Well, that's interesting, right? So, what did psychologists in the paradigm of Piaget conclude from that? Did they conclude that Piaget's approach has to be given up? Of course not. No. It was like in the Lacanian perspective in the Lacanian philosophical account, completely in accordance with that. They tried to save the core of Piagetian theory by changing the periphery. And the major idea was, I'll speak about that second point in a minute, but the major idea was, you assume that there are additional hidden variables or differences. What you say, or difficulties, hidden difficulties, you say is, well, the mountain test is not selective for the basic ability of change of perspective because it involves the additional difficulty, it's an additional hidden variable, the additional difficulty of rotating the three-dimensional picture of mountains in your mind. That is a very difficult operation. If you leave out this difficulty by choosing a very simple example, you get a much more selective test. And this test then shows that the ability, which is characteristic for the concrete operational stage, is already reached at the age of 4 to 5. So 2 years advanced. Right? 2 years preponed. So what we have to change is not the core of Piaget, but we have to change the special law as 1, right here. So the concrete operational stage is already reached at the age of 4 to 5. And we have to change the indicator law, or I1, to A1 star. I1 is the law for the change of perspective test, right? Okay. Very nice. But of course, and in that case it was confirmed. So that was confirmed. But of course the difficulty is to save Piaget's core. If really the concrete operational stage is reached at the age of 4 to 5, then all other abilities which pop up at that time have to somehow be advanced too. So for all other tests you have now to speculate that the tests were not really selective. So these are really ad hoc hypotheses, right? So these psychologists had to say, well, all other, so we now have to show that all other Piagetian tests involved additional difficulty variables of difficulty. They are not really selective because in truth the concrete operational stage is already reached at the age of 4 to 5. So that is a typical ad hoc hypothesis at that stage. If you just postulate it, it's an ad hoc hypothesis. Now you have to find, really to confirm that independently, to find these additional difficulties. So then psychologists said, well, in the case of the non-verbal number test, it may be that the children don't understand what it's meant with more or less coins. Maybe they just understand that more is meant here as a number, which means that number is a one-to-one correspondence, right? That is the principle which you may have to master to understand the concept of number. Maybe with more they just mean how much space they need or they cover. So psychologists designed a non-verbal number test. A non-verbal number test was just like an ostensive learning experiment, which I told you some lectures ago in relation to my account of observational concepts. It was just a test where kids were presented 2 pairs of cards where coins were shown, and they were asked, is it more or less, and if they said the right thing, is it the same number or not? If it were the same number and they answered in the correct way, they were rewarded, right? Somehow. Getting a candy or somehow else. So they had a certain set of training instances where they were shown these pairs of cards with different or same numbers of coin, distributed in a different way, and the question was, would they be able to learn that after a few number of training instances and then really grasp what is meant with same number already at early ages? And the answer was yes. They mastered this test after this non-verbal training phase of, they used something like 30 minutes and then they did it again. After 30 minutes training, they had a significant mastership of this test already at the age of 4 to 5. So this was celebrated as a great success for this, so to speak, revised Piagetian psychologists, right? Okay, so that, again, a typical Cartesian story. But again, it's not so easy. I mean, what is with preservation of the amount of substance? That was the first really hard difficulty. They tried to postpone this age. Somehow they tried non-verbal tests with the preservation of the amount of substance in the case of the clay, pulling apart and compressing it back. But it didn't really work. It was only advanced by something like half a year. So in that case, really, it didn't really work well. So that was already a difficulty for this enterprise of changing the periphery of Piagetian theory, right? So concerning, in other words, concerning the invariance of amount of substance, this peripheral modification, so this idea of additional difficulty variables remained ad hoc for permanently. It really never lose its ad hoc status. Right. But then, really much more disturbing phenomena were discussed. And I also did some work some 20 or 30 years ago on this problem. So, I mean, this was the change of periphery. This was a state-of-the-art of the theory in, say, in the 70s or in the 80s. For instance, a good book about the state-of-the-art of the Piagetian theory at that time is Brainerd. A psychologist called Brainerd published that book in 1978, The Development of Intelligence, or something it's called. Gives you exactly the state-of-the-art of this theory, of this state of the theory. Okay, but then, for instance, there's propositional logic. Propositional logic didn't fit at all in the Piagetian frame. Why? Because for Piaget, propositional logic belongs to the formal operational stage and should be mastered with 14 years, not earlier. And it consists of all propositional rules of propositional logic, like modus ponens and modus tollens, right? Modus ponens is the famous rule which all of you know. If P then Q, if that premise is true and P is true, then Q follows. And modus tollens is a rule saying that if you know that if P then Q, if you know this implication, and if you know not P, not Q, the consequent is false, then you conclude that the antecedents must be false too. So here, antecedent is true, consequent is true here, consequent is false, antecedent is false. And the problem is that kids master this rule already with 4 years, so really no problem with that. But they master modus tollens either with 15 or something, or they never master it at all, because there were this Bayesian selection task which saying that most of the people even don't understand the adult age modus tollens, right? So that is really a problem. So now we have a situation, you know, where the core is really in danger. Why? Because we have a system of abilities which, according to Piaget, belong to the same structural type. But some instances of the abilities are learned at the age of 4, in some instances are learned very late or never. So the whole theory is endangered. Maybe the development of intelligence is not based on the development of abstract general structures, but it's based on the development of content-specific abilities. Right? That would be the alternative. What you really learn is not the general principle at an instant, but you learn a certain kind of application of this principle, and then you generalize it successively, and this generalization is something which has to be learned too, and is part of the intelligent development process too. And that is not the case that if you learn the principle in one domain of application, then it's more or less a child's play to generalize it to other applications. That would be the alternative, which was discussed beginning in the 1980s, that maybe, you know, it's not the development of intelligence is not as content independent as Piaget thinks. And, you know, in that age, you know, in that time, although in other domains like the domain of the psychology of reasoning, lots of psychologists ask whether reasoning is maybe more content dependent or bound to specific contents as these logically minded psychologists thought. I mean, that was the same time when Kahneman and Tversky came up with their results and so on, right? Also, you know, also these results here pointed to the fact that obviously, I mean, you know, there is not this stage theory, right, going on, because really the change of perspective that is mastered already with 4 was then independently confirmed by other things like the false belief task. The false belief task is all the kind of change of perspective, and it's a quite hard fact that is also mastered something like the age of 4. So that corresponds. And as I said, I mean, for many of these experimental results, in spite of this critics, right? The experimental results were still robust, right? But they did not necessarily confirm this Piagetian account that the development of intelligence is based on these very structural and abstract abilities. It remained robust that the clay ball experiment is learned with 6. Most with 5.5 years, but not earlier. It remained robust that the numbers are learned maybe with 5, or much earlier. Change of perspective with 4, modus ponens with 4, modus tollens with 14 or never, and lots of other examples which I didn't mention here, like transitivity. So there were special results about that, which are quite robust, right? Anyhow, you know, so this was really something which endangered the core of the Piagetian theory, right? I mean, at that time where people believed in this thing, there were some, you know, that was quite influential for the discussion of the teachers, because they thought, well, if the concrete operational stage appears already at 4, at the age of 4, then maybe we should prepone school, elementary school too. You know, there were these movements having what is called in Germany preschool, and in England kindergarten, right? So we have already 1 year before elementary school, 1 year where education starts. That was also influenced by these controversies. But later on, you know, it turned out that that was really not the right way to go, because it's not generally so that all abilities of a concrete operational stage are already learned at 4. At the age of 4 years. That's not the case. It's rather so that you have to change the core of this theory. Okay. So here's another example. It's an example of the preservation of the object. It's, as I told you, very important for Piaget that the preservation, the principle, the objects do not simply pop out of existence when you don't see them any longer. When they disappear from your perception, then they don't pop out of existence. This is called the principle of the preservation of object. And this is learned at hand of the example of visual objects which you can grasp by the kid already at the age of 2 years. Right? But then the same principle is concerned at another experiment which Piaget also did, namely the experiment of dissolving sugar in water. Right? Here it is also the case that you have the piece of sugar, you put it in the water, the sugar gets dispersed, the grams get smaller and smaller, right? And at a sudden you don't see it anymore. You just see the water, right? So what do the kids say? And here, interestingly, the kids say, or even with an age of 7 or 6, they say, there's no sugar here anymore, it has dissolved. Where's the sugar? It doesn't exist anymore. It's away, it's gone. So the principle of the preservation of object is not mastered at the example of the dissolution of sugar in water at the age of 6. Again, an anomaly for the theory, right? Because it's the same principle. I mean, the principle is the principle that matter or energy, right, is preserved somehow, right? Yeah. So today in physics we call it the principle of conservation of energy, and we have the equivalence of matter and energy. But Piaget thought that the, so to speak, the preliminary version of this fundamental principle is the principle of preservation of the object, which you find also in Kant. It's a very important a priori principle in Kant, that objects are preserved, that something remains, right? So this is a problem. Piaget studied this, and interestingly, in the old Piaget, in the end of his activity, of his scientific activities, he studied this example very, very much in detail. He did a lot of experiments, and he found out, these experiments found out, we did also work on that too, they found out that spontaneously kids develop two important paradigms that were already developed in antiquity as basic accounts to matter. Some kids, namely, say that, well, the sugar doesn't exist anymore, but the water is now sweet. So there's something, so the property of sugarness has now gone into the liquid, it's sweetness, right? So this corresponds at Piaget to the Aristotelian account of continuity of matter, right? Where the matter doesn't consist of atoms, but something continuous, and now the sugarness exists now, continues to exist in the form of sweetness, right? That is one answer which the kids give at the age of 7, and the other answer is, which is of course, according to our scientific knowledge, the true answer, that the sugar grams get smaller and smaller, and at some time they are so small that you can't see them. So they are atoms, and they some still float around in the liquid, and they make the water sweet, and that's where the sugar is. So it still exists. And that's the atomistic hypothesis which the kids develop. And Piaget was fascinated, the old Piaget was fascinating that there was this parallel between the ideas which you found in the development of the children's worldviews and the ideas which you found in the history of ideas in humankind. So, but still the problem remains that the general theory core, that there are certain general structural principles which, if they are learned by the kid, then they are learned instantaneously, at a sudden, so to speak, in the form of a stage, and if they are learned, they can be applied to all kinds of examples. But this account is really untenable in view of these facts, right? Because if the same principle of preservation of the object, some instances are learned with 2 years, some instances are learned with 8 years, well, then the theory breaks down. So, in view of these results, then certain psychologists and education theorists suggested a change of the theory core. The change of the theory core was this, namely, that the development of intelligence is obviously based on the generation of certain content-specific abilities, so the abilities which are learned at a certain stage. And this experiment remains still robust, right? But these abilities are not so general as Piaget thought. Like the false belief task also is, at 4 years, is a content-specific thing, right? So, content-specific abilities which are first mastered within specific domains of application, like the change of visual perspective at hand of these four colored box, right? That would be such content-specific ability. And then these abilities are transferred to further domains of application by the operations of differentiation and generalization, right? But that is something which has to be accomplished. It's itself a development of intelligence, this generalization. So that you can say that these very general structural abilities, like change of taking over the perspective of another person in general, which for Piaget arises in the brain of the kid or in the mind of the kid at a certain time, these general abilities are the result of a development, and only in retrospective perspective where we understand that there is a general structure there, right? Only in retrospective perspective we understand, well, the general principle of truth-preserving rules in propositional logic by means of which modus ponens and modus ponens are on the same, so to speak, on the same page or of the same type. While in the genetic development, what we first learn is a content-specific ability, still somehow general, but not too general, and you generalize it. And this generalization to more complicated example takes time, and takes a lot of time. And very intelligent people, so to speak, are very good in this generalization and get a grasp of the have when they are grown up a mind by which they can really understand abstract things and abstract structure, while people who are not so well trained or not so intelligent, on what reasons, whatever, because they don't have enough training or whatever reasons, even don't get to this very abstract stage where they grasp these very general structures, right? So that would be the alternative theory core, which has then been developed. Okay. So this concludes my explanation and illustration of the developmental psychology of Piaget and follows within a perspective of philosophy of science. And are there some questions to this part? Oh, this is not time for questions. She goes on.
So,
yeah, question.
Yeah, is it always possible to identify the theory core from the periphery?
Well, in that case, it is quite easy because, you know, the theory core, well, it's a set which contains the basic, most general principles, and it's obvious that the indicator laws, they belong to the outmost periphery. That is clear, right? It is not so clear which I mean, you know, my notion of special laws, that is a matter of decision, I would say, whether which of these, the core is clear, but then you have these special laws, and then you have these indicators. Here the borderlines are somehow vague, I would admit that. But certainly the concrete age of the concrete operational stage of the other intelligence stages, the specification of that age was changed within the theory. So that is certainly not the core, because otherwise these revised Piagetian people like Breinert discusses would already said, well, we have rejected Piaget, but they didn't. So in that case it's quite clear that this also belongs to, that belongs not to the core, that is clear. I'm not sure whether that maybe these special laws are maybe way in the center of Piaget, but okay. Some other questions? Yeah?
Yes. In the case of Piaget, it seems that even though in the end the core, one of the core theses was changed, it's still recognizably very similar to the original theory, right?
You would say that this changed core, where you have a development based on the content-specific abilities which are the generalized, it's still similar?
Well, at least some aspects of the original theory have been preserved, let's say.
Yeah, that can be said. So the paradigm changed, although there was a change of the theory core, one theory core is somehow related to the other theory core by certain interesting principles. I mean, we had that already in the case of relativity theory in physics, where we even had a certain kind of correspondence principle saying that a certain domain of application, relativity theory leads to the same predictions as classical physics, right? Namely the domain of moderate velocities and moderate distances, macroscopic objects, normal-sized objects. And here, you're right, we have also an interesting relation saying that, well, the only error is that the abilities which develop in the intelligence of the kids are not as general as Piaget thought. And though there are not a few stages, but maybe the development is more gradual, but it's still something like that, right? Because there's this typical experiment where certain specific abilities arise, right? Yes, interesting, yeah. So again, a point which shows that even if you have different theory cores, you may relate them in interesting ways. And in fact, the field of cognitive developmental psychology is still very inspired by these old Piagetian thoughts. Although today the theory is much more gone into this direction of the changed theory core. Yes. So thank you for these questions. Let me now come to the final part of this lecture, namely what we can learn from our examples. So from our examples, in summarizing all what we said so far, we can now set up some very general rules for the evaluation of theories and for the recognition of what we want in science. Of course, we want to have some objective criteria for the recognition of theory progress. Okay. So we start from a picture like this, where we study the history of theories, and we have here theory history 1, a theory history, so to speak. By that we understand the normal phase in the sense of Kuhn, a normal phase of the development of theories, a research program in the sense of Lakatos, a theory history in the sense of Stegmüller. It's just a normal phase where the core of the theory remains the same, remains stable, C1, and the versions of the theory are successively changed, improved, sometimes also restricted because of anomalies or recalcitrant data and so on. So this is theory history 1. Version C1 of V1 is the first version, C1 of V2 is the second version, and so on. And then there comes a revolutionary phase where people somehow are no longer satisfied with the paradigm so far. You know, when I say theory core, I mean roughly the same as what Kuhn thought of as a paradigm, right? They are no longer satisfied with the theory core so far because the anomalies are accumulating and their ad hoc modifications are not independently testable in the explained sense. And then you have several theory cores competing each other. This is a phase which is a revolutionary phase in the sense of Kuhn. These are the 3 dots here. And then at least if Kuhn is right, but he isn't always right, then there should be, after some time, come again a phase of science where you have a second normal phase where the new paradigm, so to speak, takes over, or a new theory core takes over and is accepted by the younger generation in majority. And then you have a new normal phase where it's core 2 version 1, core 2 version 2, C2 version, V2, etc. So that's the picture, right? But since, you know, I assume that there's a theory-neutral language, a theory-neutral domain of consequences by which the theories can compare, I assume that like Lakatos and like most of the post-positivist philosophers of science in some sense, so there is a way to compare the success of theories and theory version, even if they belong to different paradigms. Right? You can also compare this with that, and not only this with that. You will see. Okay. First thing, we can still have, if a theory version is consisting, like in physics, of strict principles and strict statements, laws, we can still have a notion of falsification for a theory version, right? A theory version is falsified, TIVJ is falsified, if some of its empirical consequences are falsified by observation, right? You can still have that. Of course, if the theory is statistical, like psychological theory, we can only speak of the statistical or probabilistic rejection of a theory version. But a theory version, a full version, since it entails empirical consequences, either strictly, deductively, or statistically, a theory version can be falsified or rejected. Normally, this is the major point now, normally falsification or rejection of a theory version leads to the construction of a successor theory version, CI-VJ plus 1, with the same theory core. Right? So that is the first principle. Okay, I think that is more or less unproblematic. But then we want to compare now the success of theory versions. For that purpose, my idea is to have the notion of a success of a theory and a failure of a theory. We have to now to explicate what we mean by that. The success of a theory version is simple. That's very much the same explication as you find in Hempel, Carnap, and that you find since 50 years of philosophy of science. A success of a theory version is an empirically well-established phenomenon which is correctly explained or predicted by this theory version. Where with the phenomenon, I understand now, usually a phenomenon, when we speak about confirmation of theories, a phenomenon is itself an experimental fact. An experimental fact is itself an empirical generalization already, right? A phenomenon is, for instance, at the age of 6, almost all children master the clay ball test. That is an empirical phenomenon, right? No? I mean, a phenomenon may also be a singular fact. In some disciplines, like phenomenon, in some disciplines like astronomy, a supernova explanation is also a phenomenon, right? But in these disciplines, the passage, the confirmation of empirical laws by single data, that is what we did in section 3 of the lecture. That is the whole process of testing, rejection, acceptance coefficient, rejection, and so on. But in the confirmation of theories, what we do is, remember the 3 levels. We confirm general theories with theoretical concepts, with latent variables, by general empirical phenomena. So that is the notion of phenomenon here. Or the phenomenon is, for instance, that there's a deviation of the orbit of Mercury, which was then explained by the hypothesis of Neptune and so on. The deviation of the orbit of Mercury from the Newtonian prediction, that's an empirical phenomenon, right? Okay. So a success of a theory version is given when an empirically well-established phenomenon is correctly explained or predicted. That's unproblematic. But what is a failure? That is really the novel notion here, which I suggest and which you don't find, which is not found in decades of early philosophy of science accounts, my notion of a failure. A failure of a theory version is an empirically well-established phenomenon, which either, this is A, that is simple, that you find in many other accounts too. It contradicts, a phenomenon which contradicts a theory version. Either in the deductive sense, or at least if you have a statistical theory or a statistical empirical part of the theory, like in the Piagetian case, or like in most psychological theories, right? Then it contradicts it in the high probability sense. So it is rejected. It lies outside of the empirical prediction which a theory makes delivers lies outside of the 2 sigma acceptance zone, right? That is meant in probabilistic theory. It's also a clear thing. Okay. But a failure of a version of a theory may also be something historical, namely, here comes P. It's a phenomenon which contradicted the predecessor version of the actual version of the theory, CI-VJ-1, the formal notation. And the current version, CI-VJ, resulted from the predecessor version by postulating an auxiliary hypothesis H, which prevents the falsification of the actual version by this phenomenon and is ad hoc in the current historical stage in the explained sense. That means, apart from avoiding the consequence not P, this ad hoc hypothesis has no independent empirical support. If this is given, then the phenomenon P also is called a failure of the theory version, CIVJ. That is important. So, example, if you postulate ad hoc, right, in the case of Piaget, that there should be an additional difficulty involved in the clay ball test, so you need the clay ball test is not selective for the mastership of the invariance of substance. That is a failure, as long as you don't find, right, what this difficulty is, and as long as you don't successfully design a new test by which the mastership of the clay ball and the mastership of the invariance of the substance is advanced to a nature 4 or 5. As long as you don't have this still counts as a failure, although by postulating this hidden variable you have removed the official contradiction, it remains a failure. Or like what we had in the last lecture on the example of the deviation of Mercury. That was, I think, Mercury. The first was Uranus, the second was Mercury. The deviation of Mercury from the Newtonian orbit, the planet-like Vulcan was postulated, but never observed with telescope. The deviation of Mercury remains a failure of the Newtonian theory, even if it is enriched with the ad hoc hypothesis of Vulcan, right? As long as Vulcan is not independent observed, it remains a failure, because it's ad hoc. It's dubious, right? Everyone knows. Well, you can always introduce this ad hoc hypothesis. It remains a failure. So this is an important thing. You don't get rid of failures by introducing ad hoc hypothesis, right? Only if you confirm this ad hoc hypothesis and remove the ad hoc status by that way. If they lose the ad hoc status, then a failure is turned into a success. Only then. So this is an important news point of this story which I give for the confirmation of theories. And if you have now this notion of a success and of a failure, then the rest is quite simple, or the logical explication is quite simple. You will see. First of all, you can then say that a non-falsified theory version is the more confirmed, right, the more successes and the less failures it has. It's as simple as that. It's not really totally simple, because the more and the less, it's a question how you understand that. Anyhow, such a theory version is the more disconfirmed, or the less confirmed, the less successes and the more failures it has. I mean, that is obvious. I said there's a little complication in how you understand more or less. And this is quite simple. The more and the less should be understood in the set theoretical sense. So a theory has more successes than the others if it has all successes of the others and some more. It's not just a number sense, because if it's a number sense, if one theory has 3 successes and the other theory has 5 successes, and first of all, how do you count successes? And second, how do you weigh them? I may just predict. I have. Well, if you say the general relativity theory, but some way of saying it has 20 successes, then I come up with a theory saying, well, I predict 30 leaves lying outside at the grass, so I have 30 successes, but that's completely nonsense. I mean, you have somehow to compare the successes. So just by counting successes, that would not really lead to some reasonable way of comparison. But the set theoretical thing is of course clear, because if one theory has all successes of the other theory and still some more, then it's objectively better, right, in terms of successes. Okay. Good. This confirmed here. Now let's go on. So if you now have this, then With this notion you can say, you cannot pass or go on to the question, how do you confirm a theory core? But and here I suggest this thing. I say a theory core is the more confirmed. There are three criterion here, and these criterion are preferentially layered, though the first criterion is the most important one. And if that is ceteris paribus, then the second criterion, so that's also called a lexicographical ordering of these criteria. Right? If the first criterion is two theories are on par, then the second criterion comes into play. And if they are on par on the first and on the second criterion, then the third criterion comes into play. The first criterion says a theory core is the more confirmed its actual version is. And that's for sure. But now, assume you have two theory cores whose actual version is equally confirmed. This happens astonishingly quite often in social sciences. In distinction to Kuhn, I published on this, I had a research project on this called coexistence of rivalizing paradigms. You find it quite oftenly that two rivalizing paradigms with different theory cores coexist for a long time in social sciences, but that can happen if just the actual version is somehow equally confirmed, right? So what do you say then? Well, then it's difficult. The next criterion is, if that is the case, then you should prefer that theory whose empirical content in its actual version is higher. The empirical content is higher. And why is that possible? Because of that, what Lakatos calls the excess content. You know, if the empirical content of a theory, if that is the empirical content of the theory, then it has actually three parts. One is the confirmed part of the content. The other thing is the disconfirmed part of the content. And there is a certain part which is the excess content, which is neither confirmed nor disconfirmed, consisting of empirical consequences of the theory, where you say, well, the theory implies that and that. So far we cannot test it, but probably, presumably, in some decades we have some measurement instruments and we will be able to make these tests. Right? Like in elementary particle physics, where they found the superboson now, right? And they predicted that this test will sometime be made. What is the name of this? You know the name?
Large Hadron Collider.
Yeah, Large Hadron Collider, exactly. This K-pi mode. The giant super collider. How is the name of this strongest elementary particle which the Higgs boson?
Yeah.
Thank you, the Higgs boson. That them sometime will be able to do this experiment was predicted now for decades, right? So this is a typical example. The second criterion says that you should prefer that theory which has the strong excess content, in the case they are equally confirmed. If even in this dimension the two competing theories are on par, then the third criterion is you should prefer that theory the less its earlier version had been falsified. So that theory, a theory which has a long history of failures, from which it could be repaired by changing the periphery. If that is the case, still by meta-induction, right, you lose somehow trust in this whole research program. So a theory whose periphery is full of modifications and constructions in order to deal with all these failures is less preferable than a younger theory which does the same as the other theory but has not had many failed experiences, right? So this is the third criterion. Likewise, a theory core is the more disconfirmed its actual version is, the less empirical content its actual version has, and the more early version had been falsified or rejected. That is the dual version of that, yeah. Okay. Now, a further thing is intertheoretical theory comparison and theory progress. By means of this notion you can compare the versions of theories belonging to different cores. You can say a theory version is empirically more successful than another one if either the first theory version has more successes than the other one and less failures, without producing new failures, Or the first theory version has less failures than the second without losing some successes, right? Where the more and the less are understood in the theoretic sense. If that is not the case, the comparison of the two is ambiguous. So that would be a situation like this, where you speak of theory progress here, right? So you see here this horizontal line. Successes are upwards on top of the horizontal lines. Failures are on the bottom of the horizontal line, below it, above it and below it here. And you see the theory version C2V2 has more successes and less failures, right? The two circles are overlapping exactly in that way. Theory version C1V1 has more failures and less successes, right? So if this is given, you have an objective notion of theory progress, right? And this is a real stable notion which you should apply, right? And this situation is really given when, for instance, you compare general relativity theory with Newtonian mechanics, right? Because here they share the successes here. These are the successes of both theories in the domain of ordinary objects, but relativity theory has more successes, say, in the domain of objects moving with a very high velocity, close to the velocity of light. But what you have often, in particular often in social sciences, is this situation at the right side where you have a theory complementarity. Here, you have two theory versions, C1V1 and C2V2, and you see they have some common successes, but there are some successes which the second theory version has, which the first version does not have, and some successes of the first version the second version does not have. And the same holds for the failures. And in this situation you speak of theory complementarity. An example of this are the theories of aggression in psychology, which I mentioned already. Here you have the drive theory of aggression, according to which aggression is an instinct. You have the frustration theory of aggression, according to which people get aggressive when a certain wish they have doesn't get fulfilled. Right? And you have the learning theory of aggression, according to which people, when they exert or display aggressive behavior, just imitate certain role models which they admire. Yeah? They learn aggressive behavior. And it's well be shown that several cases the learning theory explains better, several cases of aggression the frustration theory explains better, some of them the drive theory can really explain well, spontaneous aggression without any apparent cause. So this is a typical case of theory complementarity, and in that case you simply cannot say, I mean the comparison is subjective, right? It depends on how you weigh this versus that successes. You must admit that in that case you have a complementarity of rivalizing paradigms, which may go on. So the conclusion is that the transition from one theory version to another theory version, which may now even involve a change of the theory core, right? In that part I go beyond Kuhn and all that. This transition is an empirical theory progress if the theory version is empirically more successful than the theory version 2 in this sense, right? Well, that is my suggestion. Finally we can say when it is rational to accept the theory core, based on all what we said so far, we can finally say this. And here's the suggestion, the following: a theory core is rationally acceptable as long as it is sufficiently confirmed, as long as this theory core is sufficiently confirmed in the explained sense, and no alternative theory core is available that is significantly more confirmed. Dually, a theory core is rationally rejected if it is either strongly disconfirmed or there exists an alternative theory core that is significantly more confirmed. That would be the suggestion. And following from this suggestion now, there are two important corollaries to be mentioned. First, this definition allows for the coexistence of competing theory cores, as I told you, because it may well be that two theories are sufficiently confirmed, right, but they are not significantly more confirmed than the other one. So then that would be a situation where it just, like complementary theories, where it just go on, you accept both. I mean, there is no preference. So that is allowed. But what is also allowed by this explication is something where Lakatos doesn't speak much about it. I mean, Lakatos speaks about that situation, but it doesn't speak about the other case. You may even be an intermediate stage between irrational acceptance and rational rejection. It may be that the theory is neither rationally acceptable nor rationally to be rejected. So that allows for things like being the best of a bad lot in the sense of Phasen or this critique of inference with best explanation. Let me explain to you. So the reason is that 2 is stronger than the negation of 1. Right? It may be that a theory is not sufficiently confirmed, but it's also not strongly disconfirmed. Right? Also, there doesn't exist an alternative theory that is significantly more confirmed, right? So also think about the complementary cases, but now think that the successes were really small in all competing theory. None of the theory versions is sufficiently confirmed, so it's just moderately confirmed. In that case, no theory, so to speak, is so strong that you can say, well, we believe in it, we rationally accept it. Every of the existing, coexisting theory paradigms has so many anomalies, so to speak, that we are somehow dubious about whether we should accept it. So that is also possible with this application. And finally, let me emphasize that this explication also recapitulates and replicates what we already taught and learned when we were discussing Popper's account. Namely, you see here that the confirmation of theories is twofold relative. It's relative to the current stage of observational evidence, but it's also relative to the current stage of alternative theories. So if there's a theory core which is rationally acceptable until a certain time, may immediately have to be rationally accepted. A theory core may have immediately to be rationally rejected just because another theory core comes up, right, which is able to explain all of the anomalies of the old theory core without any ad hoc hypothesis. Okay, so this ends this part of the talk, and maybe there are some questions now to this. Yes, please.
Yeah, it seems that earlier when you talked about the confirmation status of a theory, that it depended quite a lot on historical accident, basically, because it depended on the earliest version of a theory, and this sort of this is sort of an accident of how the first person who comes up with a theory formulates it. So
you mean
differently?
You mean this criterion here? Like the less its earlier version had been falsified. Yeah.
So if I had come up with a different version of the theory, maybe now I have to at first. Now I have to accept a different theory than I do up with this criterion. And it seems maybe to be to go against the principle that how you come up with a theory should be independent of the justification of the theory.
Yeah, but I mean, of course this point is controversial, but meta-induction is a very important principle, and by meta-induction I mean just the history has some relevance, right? And I mean the history collects all these experiences. So generally speaking, what you say is maybe sometimes right. So assume you have this theory version 1, version 2, and now this indicates that the periphery gets more and more complicated, right? So, because that is something which you can objectively discriminate, that there are a lot of peripheral exception clauses or a lot of peripheral, so to speak, modifications, how the theory core has to apply to this kind of example or to this area, like in Piaget, right? But there you have a non-verbal test now, but there you have the little box, and if you change the indicator laws, you have this and this. In this case, in the case of the clay ball, a change of indicator laws doesn't produce any delay or any advance of the age, right? So the periphery gets more and more complicated here. That is my point, right? So, but then you wouldn't say if someone comes up first with this theory that stage 4 has now already four stages, 4 times failed, right? Or 3 times failed. Here, here, and here. We are here now. While the other theory says it's just at that stage and remains stable, right? At 2. So then we would say, well, we put more trust in that than in that, because the reason why that has already failed so often is maybe just the paradigm here. Something is wrong here. Something is wrong here, and that is the reason why it so often had to be repaired at the periphery. That is the rationale. And you are coming now and saying, well, but what if someone comes with that in the first place? But that is improbable. But because why should one come with such a complicated periphery in the first place?
But isn't then the real problem why we might reject the first theory that it has such a complicated periphery?
Yeah, that may be one way to put it. But often you just cannot really. I mean, what is much easier to access is the history. How often has it failed? So, for instance, well, I could give you some examples. But for instance, the Marxistic theory of the economy, the Marxist theory of economy has so many wrong predictions. So there were so many attempts to repair it, right? The law of falling profit rate and these things, that it's just somehow you lose trust, things like that, right? Or the law, I don't know. I mean, there are just lots. If you speak with applied scientists, they just would say things like that this paradigm has so often failed that I don't want to go for that. I believe I want to do something new. I'm not confident that will finally be a version which succeeds, right? And I go with that. Yeah. Any further questions? No? So if that is not the case, then let me say thank you for all you who were sitting in my lecture, all of you, but also all people on the internet who are listening to my lecture. I hope you enjoyed it and you learned a lot of it, because this today is the last lecture of my course Philosophy of Science, and I wish you all the best and much luck and much motivation and good development in your future occupation and activity within analytic philosophy and philosophy of science. So thank you.